Hello everyone. Today we will start module 8, that is on landslides. So this is lecture 28, Introduction to Landslides, right. So many of you might have experienced the landslide, many of you might have seen the landslides, and probably you will be able to perceive that how devastating it could be, right. So in today's lecture we will learn more about the landslide. This is introduction to landslide. We will see different characteristics. So let us start this course. So here you can see this video, how devastating a landslide could be. You just see this video carefully, how devastating it could be. In another video here, you can see that what is the scale of this landslide. So it is not always that landslides are of this much of a scale. This can be a smaller landslide, this can be a larger landslide. Landslides are the downward and outward movement of slope forming materials composed of natural rocks, soils, artificial fills or combinations of these materials, right. You can see here. So these two videos are meant only to tell you that how devastating a landslide could be. So landslides are the downward and outward movement. So what are the properties here? So here you can see different components. So this is the main scarp, right, and this is basically your head, and this is the foot, right, and this we call toe. Now here you can see this is crown crack, this is the crown, this is the surface of rupture, right, and this is the main body. This is the main body, this is the main mass of this landslide. Toe of surface of rupture, so this is the toe, because you see this is the surface of rupture here and this is the toe of the surface of rupture, right. This is the minor scarp here, this is transverse crack, transverse ridge, these are the ridges, right. This is radial crack, right, you can see here, and toe we have already seen. This is the foot and this is the surface of separation. So this is the surface of separation, right. So these are the different components of a landslide. So typically you will see all these features in a landslide. So but schematically it is very easy to demarcate the boundary of this, but naturally when you see a landslide it will be not so easy to demarcate the lines, and you will be able to say that this is the crown, this is crown crack, minor scarp or toe of the surface of rupture. So you have to critically see the features of a landslide. The factor leading to the failure of slopes can be classified into two categories. So here you can see this particular hill has failed. So this slope has failed and the material is on this particular road, right. So this is a typical landslide. Now when we say a landslide, it is basically the failure of the slope. So whatever material is there, that is going to fail and it is going in the downward side, right. So this landslide can be classified, or the failure of the slope can be classified into two major categories. The first one is the factor that increase the shear stress, and the second one is factor that reduce the shear strength of the soil. So here you have a slope. So either shear stress has increased or shear strength has decreased, this particular slope is going to fail, and then we will have this kind of landslides, right. I hope this is clear. Increase in shear stresses, because shear stress is playing a major role here. So, how we are going to evaluate that what parameter is going to increase the shear stress of the material, or what parameter is going to reduce the shear strength of the material, right. So, let us see first increase in shear stresses, increase in slope angle because of the change in the geomorphology of that or change in some geological structure, right. So, let us say this is the slope which we are targeting, and here this is in the stable condition. Now, there are two ways it can fail, either shear stress will increase or shear strength will decrease, right. So, when we are saying shear stress will increase, so if I increase the slope, so now how slope will be changing because of the weathering. So, probably there is a erosion here and now this slope is like this. So, the angle is increased, right, the slope is increased. So, that is because of the natural activities. So, natural processes are always acting on the surfaces, and because of that you are having change in the slope angle. Then next is removal of lateral or underlying support because of erosion, previous slide or road cuts or quarries, right. Now, suppose this is the slope and it is actually in the stable condition because here you have something which is holding the material here, right. But subsequently what happened, because of the change in the lateral or underlying support, right, from here or maybe from here, this slope will start failing because material will not hold here at this particular slope angle. Now, the next is increase of weights because of the rain or snow accumulation, fills, vegetation, this weight will increase, right. So, here because of the growth of the vegetation, maybe the trees, right, the weight is increasing, or because of the rainfall, or maybe because of the snow accumulation, right. All this will change the weight of this particular surface, right. So, in such situations shear stress will increase. Now, the next one is the transitory stresses. It is because of the earthquake or vibration due to heavy vehicle movements, then heavy machinery in a particular area, because of the blasting. Many times we use the blasting to create the roads, right. So, these will increase the shear stresses. Now, the next comes is reduction of shear strength, increase in pore water pressure, weathering of a material, change in structure because of the failure plane, fracture or unloading. So, here the loading was also a reason, here unloading is also a reason, right. So, because of the change in the natural equilibrium, the slope can also fail, and the first one is the increase in pore water pressure. So, one thing that a particular surface is receiving a normal precipitation, right. So, here the soil which is available in this particular area, so there are different soil and rock layers, right. Because of this rainfall or the precipitation, what will happen, this soil or the material will get saturated, and because of the saturation the pore water pressure will change. So, increase in the pore water pressure will reduce the shear strength of the material. That is one of the very important parameter which is changing or shifting the shear strength from a stable to unstable regime. When we talk about the shear stress, because shear stress is one of the important parameter in slope failure. So, if you see, shear stress is the force per unit area acting parallel to the plane of the surface. So, here this is the surface, right, and this is the force which is acting on it, right. So, how do we calculate? We calculate using this formula, and here we use shear stress, this is the tau, then F is your applied force, A dash is the cross sectional area of the material, this is perpendicular to the applied force vector, right. The particulate nature of the soil translates all the different loads to shear stresses. This is very, very important, right. So, here all the different loads are transferred or it is translated to shear stresses when we talk about soil, right. So, here because of any external forces, the forces will get converted into shear stresses. Now, we will talk about shear strength. The shear strength of soil is its resistance against shear failure. So, when we are talking about this particular slope, right. So, how it is resisting to failure? It is because of the shear strength, right. So, the shear strength of soil is its resistance against shear failure. I hope this is very simple and very clear to you. Shear strength can be approximated by the equation which is here. Here the tau is equal to effective stresses, here you can see, then here you have angle of internal friction which is here, tan of angle of internal friction, then C is the cohesion. Now, we will try to understand with the help of this figure. This figure is basically normal stress versus shear stress. So, this is the normal stress, right. Now, this particular area, it is basically your cohesion and this is your angle of internal friction, right. So, how we are utilizing these information to calculate the tau which is basically your shear strength, clear. Now, we will try to understand this stability of slope in terms of shear strength and shear stress. So, when this is the condition, when shear strength is greater than shear stress, it is in the stable condition. So, we call it stable slope, right. Next one, where shear stress is just above the shear stress, we call it metastable slope. So, it is not very stable compared to this condition, but it is in the metastable slope. Now, the third one, here you can see the shear strength is less than your shear stress, this is unstable condition. So, slope is in the unstable condition, clear. So, here you can expect the landslides. Now, different causes are there, some of them are anthropogenic, some of them are natural. So, let us start with the natural causes. So, here you can see the heavy rainfall, this is one of the important parameter which is triggering your landslides. Then tectonic activity, because this tectonic activities will provide the vibration, right, and this will change this material property temporarily and then this particular slope will fail. Then vegetation cover, if there is a growth of the vegetation here, that will also change. If there is a removal of existing vegetation under which it was stable, then also it is going to fail. Then weathered material, so the weathered material will have less strength. Then seared, jointed or fissured material surface, so like bedding, cystosity, fault, unconformity, that will also have less stability, right. Then other hazard like flood, volcanic activities, glacial movement or erosion, etc., that will also trigger this landslide. Then the last one is the natural loading on the slope or on its crest, that will also trigger, or that may also cause the landslides. Now we will talk about the anthropogenic activities. The first one is the excavation of slope or its toes, right. So, when there is a slope and we are trying to remove some material from here or from here, or we are disturbing this slope, that will also cause to fail it, right. Then loading of slope on its crest. So, there is extra loading because of some construction, right, or maybe big houses or restaurant or maybe hotels, that will also bring extra burden on this particular slope. Then drawdown of reservoirs. So, let us say here this is a river and here you have a slope, right. So, under normal condition, groundwater table and surface water, this is stable, but if there is a change in the water table or the surface water, what will happen? There will be change in the moisture condition of this particular block, right. Because of that also these slopes can fail. Then irrigation, mining, artificial vibration because of some heavy vehicle movement in this particular area, that will cause the vibration. Then water discharge, if you are putting your discharge channel or the outlet through this, maybe this will change the stability. Then deforestation. So, here if you have the vegetation and that is getting removed because of some anthropogenic activities, that will also change the stability of this slope. This particular table is from Selby 1993. So, here you can see he has made a very nice table, that is natural causes, and it is listed into 3: geological, then morphological, then hydrological, and then we have this anthropogenic causes. So, when we talk about the geological causes, so here you have weathering, then structure is also taking place. So, this geological causes are divided into 2. So, here you have weathering and the structure, and the weathering can be physical, chemical and biological weathering, and the structure, the stratification, orientation, that will also cause this landslides. Then when we talk about this morphological causes, so here you have topography, because the surface is always getting modified because of the natural agents, right. So, the topography is getting changed. Then surface covers, slope inclination, the slope angles, that is getting changed. Then because of the erosion, you have toe erosion, gully erosion and subterranean, right. Then you have deposition on slope faces, on crest, on both, if there is a deposition, right. So, that will also change the stability. Then you have tectonic activities. So, because of the upliftment, there is a change in the angle, right. Now, when we talk about this hydrological causes, so rainfall, infiltration, seepage of pore water, rise in groundwater level, that will change the stability of this slope. Now, this anthropogenic activities, so here you have encroachment, deforestation, unscientific cutting of hill slopes, unplanned infrastructure development, all these have major role, or that is why we are calling it causative factor, right. So, these are causing the landslides. If you see this particular graph, so here it says time influence of predeposition and triggering factor on instability. So, here this is the self-explanatory graph. Here you can see this is the pre-failure, this is the post-failure, and here how it is getting changed, right. So, here you can see this is because of the heavy rainfall, this point is here, and this is unstable, this is stable, right. So, this is metastable, Now here you can see that because of the high rainfall, this unstable zone is coming, right. Here you can see the land use, then hydroclimatological tectonism, lithology, soil structure, glacial heritage weathering, heavy rainfall, erosion at toe. So, all these are having major role on the stability of the slope, and x axis is basically your time. So, the predisposition factor, the time scale is given, triggering factor, here you have time scale, right. So, let us see, I have a few images so that you will understand the scale of the disaster when we are talking about the landslide and different causes, how they are playing a role in triggering this landslide. So, when we say heavy rainfall, so you can see here this particular landslide, it occurred because of the heavy rainfall. So, how it is on the surface. This is because of the water level changed along coastline. So, there is a change in the coastline, so the water level changed. So, because of that stability will be different, and then this kind of landslide are very common along this coastal regions. Here this is because of the flood. You can see that because of the flood the stability will be lost, and then you will have the landslides, right. This is because of the lahar which is caused by volcanic eruption, right. So, what happens during the volcanic eruption, this material will start flowing, and that will also cause or change the stability of this slope, and then you will have the landslides. This is very easy to understand. You can see all these material are because of the failure of this particular hill, right. So, it is because of the earthquake. So, when we talk about the criteria, now let us understand how can we classify the landslides. So, a phenomenon involving such a multitude of combinations between the material and disturbing agents open unlimited vistas for the classification, right. So, based on that you can have many criteria to classify these landslides. So, let us understand one by one. So, the criteria for identification and classification of the landslides. So, the first one is the type of movement, how the material is moving. Then comes the kind of material, what kind of material we have. Then rate of movement, at what velocity it is moving. Then geometry of the area of failure and the resulting deposits, right. Then what is the age, what are the causes. So, based on the causes also you can classify the landslides. Then degree of disruption of the displaced mass. Then comes the relation or lack of relation of slide geometry to geological structure, degree of development. Then geographic location of type examples, then state of activity. So, all these have been used by various researchers to classify the landslides. So, let us understand one by one. So, based on the velocity scale, here you can see the type of movement, the falls, topple, then you have slide which can be rotational or translational, then lateral spread, then you have flows, and then you have complex. So, when we talk about the type of material, here you have bedrock and soils. So, when we talk about the soil, you have predominantly coarse and fine material. Then based on these rocks and soil, we have categorized it into different category. So, the falls will be called rock fall, and the coarse soil, that will be debris fall or earth fall. Then topples will be rock topple, debris topple or earth topple. Then you have rock slide, debris slide, earth slide, rock spread, debris spread, earth spread, rock flow, debris flow, and earth flow, right. Then you have flows, the next category, deep creek and soil creep. Then in the complex you have combination of two or more principal type of movement. So, this is also very evident in the field. So, you can have multiples of landslide of different nature and those will be categorized as complex, right. Now, we will see classification of landslides based on the type of material. So, here you can see the type of material are of two type. So, the bedrock and the soils, right, and the soils are categorized into coarse and fine. Now, here the type of movement we have, that is fall, topple, then you have slides which is classified into rotational and translational, then you have lateral spread, then you have flows, and then complex, which is the combination of 1, 2 or 3 different types of landslides. When we talk about this first category, falls, so when we have the bedrock, it is called rock fall. When we are talking about the coarse soil, that is debris fall, and then fine soil, that is earth fall. Then for the topple, you have rock topple, debris topple, earth topple. Then you have rock slide, debris slide and earth slide. Then rock spread, debris spread and earth spread. Then for the flows, you have rock flows and the deep creep, then debris flow, earth flow, and for the soil you have the soil creep. And the complex, as I mentioned before, the complex will be the combination of two or more principal type of movement. So, based on the type of the material, this landslide can be categorized into any one of them, or it can be a complex in nature. When we talk about the velocity, how we can characterize or how we can classify these landslide based on the velocity, rate of movement. So, you can see here the velocity is given here, right. So, when we talk about the first extremely slow, it is less than this velocity. Then you have this, and less than this and greater than this, that will be your very slow. Then you have slow, moderate, rapid, very rapid and extremely rapid. And here probable destructive significance, major catastrophe, escape unlikely, velocity too great to permit total evacuation, escape evacuation is possible. So, below this escape is possible, right. Then structure can be maintained with frequent maintenance. So, here less than this, right. Then you have instrument construction possible with precautions. So, here this is safe one, because here we are talking about the extremely slow. So, we will see one by one when we will talk about the type of landslide. So, here this is the description and this is the velocity, here you have the significance, right. This particular graph is nicely representing the different landslide and their velocity. So, here you can see the rock avalanche, that is having the highest velocity, right, it is here. When we talk about the debris avalanche, it is here, mud flow, it is here, debris flow, that is again in the higher side. Then earth flow, that could be very low to moderate, right. Then clay flow slide, that is again high. Then sand slide debris flow slide, that is again high. When we talk about this earth flow, that is only having the moderate velocity, right, but others are having very high velocity, or the rate of movement is very, very high. So, in this slide I am trying to tell you the multidisciplinary nature of landslide studies. So, the geography, geoinformatics, geology, geomorphology, geomechanics, hydrology, hydraulics, hydrogeology, structural engineering, statistics and artificial intelligence, everything can be used or it can be studied with any of these perspectives. but the best way to resolve or to characterize a particular landslide, it is when you are having people from all these domains together, that will give you the more better, or that will give you fruitful result, right. So, once you incorporate all these aspects, then your work will be very nice. When you involve the different aspect which is discussed here, as landslide has the multidisciplinary nature, so it is always suggested to have the different aspect which are discussed here when you are going for the landslide studies. So, with this I will end the part 1 of this lecture. We will continue this introduction to landslide in part 2. Thank you very much.